Hi everyone, I hope you are doing good. So let's take a new DSA question here, and this would be the third video in this view series, binary view series, where I have already covered the left view, right view, and top view. And now today we will look at the bottom view, right? And I hope you are now very clear with the views of the binary tree, correct? So let's take this question here. So here one binary tree will be given, right? One binary tree will be given, return an array where elements represent the bottom view of the binary tree from the left to right. So if there are multiple bottom most nodes for a horizontal distance from the root, then the later one in the level order traversal is considered. For example, in the below diagram, 7 and 34 are the bottommost nodes at a horizontal distance of 0 from the root, and here 34 will be considered instead of the 7. So what it is saying, basically, I hope you are clear with the distance now, because in last video we have calculated the distance, right? So here what is it, basically what it is trying to say. So here this is the given tree, right? Let me write it here, 20, right, and this is 25, correct? So this is the given tree. So now see here distance, how we will calculate distance. So we just draw horizontal lines, right, top to bottom, correct, and we consider this root is at the 0 distance, right? And when we go left side, when we go left, right, so we do -1, and we go right, then we do +1 for calculating the distance. So right, so we are going left side here, so this would be -1, then this would be -2, because from here if we go left, then 0 plus -1, that is -1, and then from here we do again -1, right? So -1, that is -2. From here on this 8th node, right, from this 8th node, what we are doing, we are doing +1 here because we are going right side. So here this would be at a distance of 0, right? And from here same, we are going right side, so we will do +1, and the distance of this would be +1, right? And from here itself, if we go right side, then again we will do +1, so this would be 2 distance, right? And for this 34 from 22, we are going left side, so we will do -1. So whatever the distance it is having, it is 1 minus 1, that would be 0. So it is 34 will again on the 0 distance from the root node, correct? So I hope now you are clear with the calculating the distance. Just keep in mind, when you go left side, just do the -1, and when you are going right side, just increment it by 1, right? Just do the +1, correct? So that would be the distance from the root, right? So now let me clear this one first. So now I hope you are clear with the distance. Now if we talk about levels, right, so just draw horizontal lines here. So these are the basically levels, right? So if I consider 0, 1 and 2, so say 0 would be higher level always, right, and 1 would be lower level, correct? So if we look from the top, from the bottom, right, this way, then we can always see the lower levels, right? It might be a case where lower level value can hide the higher level value, right, or top level values basically, right? And how can we say that? So if, when we draw, when the values will be on the same distance, then we can then we only see the lower level values from that same distance from the root, right? So let me draw horizontal lines as well here. So these are the distance lines, right? Horizontal lines would be distance lines, and the vertical lines would be distance lines, and horizontal lines would be level lines. So see here, 7 and 34, these are at the 0 distance, right? Distance is 0, 0, 0. We have already calculated in a couple of minutes back, right? 1, 2, this is -1, this is -2, right? So these 7 and 34 would be 0th level, 0th distance, right? And these are the on same levels. So here it is already mentioned, if bottommost nodes for a horizontal distance from the root, then the later one in the level order traversal is considered, right? So if two values are at the same level and same distance, then we have to consider the left value or the later one, right? So here 7 comes first and the 34 comes second, right? So we will consider 34. So this is now clear. So 7 and 34 we will consider 34. Now if we look vertically, then 34 and 20 are at the same distance. So in this case, as we are looking from the bottom, so we can only see 34, right? Why? Because 34 will hide the 20, right? That 20 value will behind the 34 value. That is why. So now both the things are clear. If if two values are at the same level and same distance, right, then we have to consider the right value, basically this one, later one, that is 34, and then we have to take the lower level value, that is 34. If we compare 20 and this, because 20 is having at the 0th level, that is the top level, and this is the lowest level, right? That is why. I hope it is clear now. Now think about the algorithms. How can we solve these problems, right? I hope you know now better, because in last 3 videos we have already covered left view, right view, and top view, right? And top view is similar to exactly similar to this one, right? There are little bit difference only, right? There we were looking at the tree from the top, and now we are looking at the tree from the bottom side, right? So if we tweak some conditions in that solution, so that also solve this problem, right? So here there are multiple solutions. What I consider is, the first one is we can make use of the recursive approaches, right? Recursive approaches, that would be like pre-order, post-order, or in order, right? And the iterative approach we can apply here, right? That is the level order traversal. So in last couple of videos, I have explained with the recursive approaches, pre-order approaches, post-order approaches, right? And so we solved the left view, right view, and top view. Now today we will take a look at the level order traversal. Like we will solve the problem this bottom view using the level order and also pre-order also. So quickly just have a look at this code. So this is similar to the not exactly similar, but yeah, little bit similar to the previous video code, where we have solved the top order view, right? Top view using this pre-order traversal. So here we are just I have just altered this condition here, right? So in that video, if the level is lower, the level value is lower, it means the higher level, then only just update the value, else skip it. Now here what I am doing here, I am basically here, if the level is higher, the level value is higher, it means the level is lower, right? So this is 0, 1, and 2. So 2 value is higher, right? So don't be confused with the higher level, top level, like lower level. So this would be the lower level, right? So if the level is high, greater than the whatever the inserted values level, then just update the value. Then also just update the value. So that is what I have altered here, right? And then go left and check also, right? And so I'll skip this one. Now I will come to the second approach here. So this is the second approach, level order, using the level order traversal. So here what I am doing, I am just taking one queue, right? As you know, when we go through the level order, we have to take one queue, and in that queue, if we have to print only level order nodes, then we take only nodes. But here we have to print the bottom view. So that is why I am taking pair of node and integer here, right? So here node and the integer value would be a distance, right? The pair of node value and node and the distance, right? And I am taking one map of horizontally distance, right, and the node value, right? And this map would be used for the storing the results. So I am inserting the root, right, and the distance of that root, whatever the node we are inserting into the queue from the root, so that would be 0 initially, correct. And then I am going inside the while loop here, right, and I will iterate through this while loop until we get the empty queue, correct. So here I'm taking that we have already inserted one node into the queue, right, so that is not the empty queue. So we will go inside and we will take out that inserted node queue dot front, right, and then we will pop that out. We will remove that node from the queue. So for example here in this case, right, so this is my queue, so I have inserted one already here, right. Now I have inserted one, so I'll take this out, right, and then I will say I will take because this would be now 1 and 0, so this would be inside queue, right. So I'll take this out because we are inserting, see here, root and 0. 0 is the distance from the root and that node itself, correct. So I'll take then p dot first, that would give my give me the node, and p dot second, that would give me the distance from the root, right. So here distance would be 0, right, see 0 and 1. So now I will insert the value at this distance. So distance is 0, so this would be my map. So 0, I will insert what I will insert, the node value. So node value is 1 here. Node arrow data, I will insert it, right, and then I'll go to the left. Then I will go to the left, right, and if not is left is not null, then I will insert. So what I will insert here, so let me remove this one from the queue, because queue is not having that much space. So here I will insert 3, right, and the distance from this one, so it would be -1. So here -1, correct. 3 and -1 I will insert, and then I will check for the right also, because we are at root, so right is also there. So we insert 2, right, and 1, correct. Here right side we will add +1, right, we will increment the distance by 1, correct. So +1, that is what we are doing here. Now we will go up and check queue is empty. No, queue is not empty, so we will go inside and we will take the front value, so that is -3 or sorry, 3 and -1. So the node is 3 1 and the distance is -1. Then we will check for -1. Yeah, nothing is there on -1, right. So as this is the map, so it would always store the value in sorted order. So -1 will have the 3, right, node arrow data. We will add from here, and then we will check for the left. So left of this 3 is null, so we will not do anything. Right of this 3 node is null, so we will not do anything. And then we will go up here, we will come up here at the top of the while, and queue is empty. No, queue is not empty. We are still having one node here. Here see, we are popping it out. That is why I have deleted this one, right. So now we are having one node here, so we will take this out also. We will also take this out, correct, and we will pop this out, and then we will say p dot first. So p dot first, that is node is 2, right, and the distance is 1 here. This distance is 1, so at 1 we will insert this 2, correct, and then we will check for the left of this one, right of this one, correct, and this is now empty. Queue is now empty, correct. So we will come up here at the top of the while and we will check q dot empty is true. Yes, so this condition would become false and we will come out from this iterative while loop. And now in our map we have, this is our map. Now from this map we are taking out the node values, as it is already sorted from -1 0 and 1, right, on the basis of the key, and our question is also demanding the same, just print the node values from left to right. Right, so that is why we will print 3 1 and 2. That is our answer, 3 1 and 2, correct. So I hope you understood this approach. This is level order, using the level order approach, right. This is similar to the this pre-order, post order, or in order traversal techniques, right. So if you know the level order traversal techniques, then this is very easy for you. If you know the pre-order, post order, or in-order traversal techniques, then the recursive approach would be very easy for you. So you can use whatever you like, right? So that's all for today. If you have any comment, query, or doubt, you can comment below the video. I will reply there itself, as well as if you want, I can cover those your doubts into the upcoming videos. Yeah, thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.